031, March 26, 28, 2026. Right now marks 2,400 and 2,249 hours of progress on the global heart simulation. Currently, the system for doing tens of thousands of raycasts against thousands of objects simultaneously has been improved, in that the accuracy of it is now 100%, and that the rays will always correctly follow the object's rotation. As seen in the last video, there was a bug in which when the object rotated in certain directions, the grid of rays would flatten, and what was discovered as the cause of that was testing against the world axis of the object's position instead of the local axis of the position and rotation. So currently the rays are computed, and then they are tested against the local axis of the object, and the final step is converting that to world space rather than using the world space earlier. And so what was done to improve the performance somewhat was what was looked at was the profiler, and the profiler indicated that certain functions were being called thousands of times, and so what was seen was that in the function, it's basically a for loop that iterates over thousands of rays, and what was seen is that in that function, the angle of each ray is calculated, and that was calculated using information from the object's transform, such as its forward vector and up vector and right vector, and what was seen was that those values are actually shared by every single ray and don't need to be computed for every single ray, so moving those outside of the loop improves the performance somewhat, and the intention going forward is to actually add multi-threading to it, as currently it's being done on a single CPU frame, which seems to be indicated here as the time in milliseconds for the frame time is actually quite high, though it was actually expected to be far worse than this. The actual thought was that it would be in the single digits, but for now it's able to at least do 16,200 raycast checks per second against thousands of objects. And so the intention going forward is to add multi-threading to it and then see how that performs, and the goal is to be able to do 50,000 raycast checks per second without really affecting the performance. And if that doesn't work, then a GPU driven system could be looked into, and then the goal would be 100,000 using custom raycasting mechanism on the GPU, though that would probably require something with the voxels, as the overall goal for the line of sight system was to have it work with the 3D voxel system to create the fully three-dimensional throttle wall system that can account for multiple elevations and floors and leave a persistent trail behind, unveil the map in real time, no matter the rotation or angle of the eye object or origin of the rays. And so that's the intention going forward, to make the system as robust and efficient as possible, though the immediate goal is to learn more about the engine's multi-threading mechanisms and see what results those give.